Do you know, according to Google, problems on palindrome are the most commonly asked question during the technical interview. Hi, my name is Anindo and welcome back to my channel, and over here today with the help of a single solution we will be solving 5 problems for our technical interview. So it's more like 5 problem 1 solution. So without wasting much time, let's start with today's video. But before that, if you like this video, please do like and share this video, and if you are new to my channel, do not forget to subscribe to my channel and hit the bell icon so that you never miss an update from my side and you're always ready for your next interview. So today we will be solving 2 most important problems. The first one is we need to find out all the palindromic substring in a string, and number 2, we need to find out the longest palindromic substring. So over here, if you carefully notice, both of the question is actually different. One is talking about finding all the palindromic substring within a string, and the next question is telling about find the longest palindromic substring within that string. But the fun fact is the solution of both the problem is more or less same. Just by changing the solution a bit, we can actually get both the solution over here. And in this way, at the end of the video, I will be giving you the rest 3 problem that you can also solve with the help of this similar solution. So without wasting much time, let's first understand the problem and let's see how with the help of a single solution, we can easily solve so many problems during our technical interview. So let's first solve the problem of finding all the palindromic substring within a string. So let's first understand that what is a substring. So a substring of a string is defined as a part of the string in which all the characters are contiguous to each other. So over here within this string Google, you can see that the string that is GOO or GO, which are line contiguous to each other, are actually substring. Which means that if I try to write all the substrings over here, GO will be a substring. Similarly, GOO will be a substring. GOOG is also a substring. And in this way, there can be plenty more substring over here. But one thing you have to remember that all the characters within this substring should lie one after the another. Whereas in case of the subsequence, which is another variety of a string, over there the definition of the substring is it is a part of the string, but it is not necessary that the character of the string will be contiguous to each other. Which means over here GLE can be a subsequence. So over here you can see the first G is lying somewhere over here, the second G is lying somewhere over here, and so on. So over here within this subsequent, all the characters of this subsequent are not necessary to be contiguous to each other. So this is the main difference between the substring and the subsequent. So over here now if you see, the problem statement is telling that we need to find out all the palindromic substring within the string. So if we try to break down this problem into sub-problem, the first problem statement is we need to find out all the substrings that can be generated from the string, which means that we need to find out this set of substring which can be produced from this given string over here. And within this set of substring, we need to find out the palindromic substring over here. So a palindromic string is nothing but a string which is equal from both sides. So over here, if you consider this string that is GOOG, so you can see that if we divide the string into half, this string will be equal from both the ends. So this is basically the definition of a palindromic string. So in this way, after finding all the substring from a given string, we need to find out all the substring over here which are palindromic in nature. So over here, after generating all the substring that can be formed, you can see that the 2 palindromic substring that can be found over here are number 1 OO and number 2 GOOG. So these are the 2 palindromic substring that you can find out from this string. So I think this is clear to you. So the first problem statement tells that we need to find out all the substring which are palindromic in nature, and the second question tells that we need to find out the longest palindromic substring over here. So you can see that over here within this set of palindromic substring, this substring that is GOOG is the longest palindromic substring. So normally if you go to the other solution for solving the longest palindromic substring, you will find out that the most of the solution talks about the dynamic way of solving the problem. So I hope you know that what is the dynamic program. So over there, most of the solution tells that how you can solve this problem in a dynamic way. But very frankly telling, dynamic programming is a bit complicated if you do not know or understand the entire programming. So to avoid the dynamic programming solution for this problem, you can actually go with this solution that I will be providing over here. Because the way we will be solving this problem will be very easy, and you will see that you can easily remember and you can do it during your actual interview. So without wasting much time, let's first discuss that how we are planning to solve this problem. So for the first time, we will go with the brute force approach so that it will be easy for you to understand the basic solution or the basic way how we are planning to solve. So let's go with the brute force approach of solving this problem, that is finding all the palindromic substring within a string and also finding the longest palindromic substring within that set. So let's start with the brute force approach over here. So the brute force approach of solving this palindromic substring is pretty easy and straightforward. But over there is one issue, and that is complexity. So let's first see how we will solve the problem using the brute force approach. So to solve the problem using the brute force approach, we will be going with finding all the substring that can be generated over here. And for that, to generate the substring from a given string, we will be using two for loops. So let's first write the two for loop that will help us to generate all the substring from a given string. So over here I've just written the pseudocode or the basic logic of this program so that it will be easy for you to code in any language. So over here you can see I have started two loops, one for loop starting from I equal to 0 and another for loop starting from j equal to I. So what actually happening over here is like, for example, over here for the string Google, we are starting two loops, one starting with the first index, that is I over here, and another starting with j, which is also pointing to I for the first time. And over here if you see, the substring of ij is nothing but g over here. So if you see over here, g, that is a single character of the string, is also a substring of a given string. And also if you see, this is a palindromic substring, because a single character of a string is obviously a palindromic in nature, because it is always equal from the both sides. So right now over here, if you see, there can be multiple substring that can be generated from here. So each and every character of this string is basically a substring which are palindromic in nature. So let's first see how we are solving this problem over here. So this problem will actually calculate all the substring that are possible to be generated from this given string. So for the first time, it will point to I equal to 0 and j equal to 0, which means that our substring that we will be producing will be g. On the second iteration over here, that is when j will increase by 1, the j will actually point to this index, that is j will point to 1. And over here, this substring will result into go. And in this way, as long as we increase the value of the j, over here you can see that the substring will keep on generating something like this, and so on. So in this way, it will keep on generating the substring. And on the next iteration, when the value of I will become 1, at that time iteration will begin from here, which means that the first substring that will get generated for I equal to 1 is O. And after that, it will be O, then OG, and so on. So in this way, on each and every iteration, we are actually generating all the substring over here. Now the problem statement tells that we need to find out the palindromic substring over here, which means that over here we need to put one condition, and that is we have to check that if this substring which is getting generated from here is palindromic or not. And if this function, that is palindrome, returns true, then we can predict that the substring is palindromic in nature. So I hope this is clear to you, because this is quite a simple approach of solving this problem. And if you just calculate the complexity of this program, you'll see that the complexity of finding all the substring over here is order of n square, since we are iterating 2 times over here using an inner for loop, and over here to find whether a string is palindrome or not, we are using another functionality, that is palindrome. And you know that the complexity to find a string as a palindrome or not is order of n, which means that the complexity of this function will be order of n, and the overall complexity of this problem will be order of n cube, which is actually quite high for the real-time scenarios. So over here we need to find out a better solution which can result into a less complex algorithm. So let's see how we can solve this problem using some other algorithm which will result into an optimal solution. So I hope you guys are clear with this basic solution that how we are solving this problem using the brute force method. So over here you can also see that you can also calculate the longest palindromic substring from here by just putting another condition within this if block, that if the palindrome is a substring, then you have to again put a check that whether the length of that palindromic substring is greater or not. So just by putting one more condition over here, you can easily get the result over here for the longest palindromic substring. So I hope right now you got the idea that why I am telling that all this problem on palindromic substring are interrelated with each other. And if you know the solution of only one program, you can actually solve all the problems related to palindromic substring during your interview process. So without wasting much time, let's start with understanding that how we will be solving this problem using the optimized solution. So the way by which we will be solving this problem using the most optimal solution is pretty easy and straightforward. So you will notice that a string which is palindromic in nature can be of two types. Number one is the odd palindrome and number two is the even palindrome. So if you just remember, I have just told that the substring of this string is nothing but each and every character over here. So G is one of the substring. Similarly, O is another substring. Again, O is another substring. Then again comes G, L, and so on. So over here, each and every string is a substring. And not only that, since a single character is a palindrome, that is why this is a single character palindromic substring. So over here, if you just see, these are all the examples of the palindromic substring. And if you just look at this carefully, these are all the palindromic substring of odd length, because the length of all the substring over here are odd. So I will mark this as odd palindrome. Now the next set of palindrome or the next set of palindromic substring that you can see over here is double O, which is actually nothing but an even set of palindrome. So if you just think deeply, you can easily conclude that the palindromic substring within a string can be of two types. Number one is the odd palindrome and number two is the even palindrome. And this will be our key point to solve the problem. So let's see how we will be solving this problem. So over here, we will be running a for loop from I equal to 0 to I equal to n, which is the length of the string. And over here, we will take each and every character as a special character. That is, we will consider each character as the middle character of the palindrome, which means that all the characters which are lying beside it on the left side and the right side should be equal. So over here, if I take an example of an even length palindrome, let's consider a string that is PAL, LAP. So you can see this is a 6 character substring and this is an even length palindrome. And let's take another example of palindrome, and that is PALAP. So obviously this words doesn't have any meaning, but let's, for the demonstration purpose, I'm taking all this example. So let's see how we are planning to solve this problem. So over here you can see this is an odd length palindrome. And over here, what we will be doing is, on each and every iteration on this string, we will be considering that the string or the character which we are getting for the value of I is the middle character of the palindrome. For example, for I equal to 2, over here for this string, the pointer will be over here, right? Because over here, the caret function of I will result into the L, which is the middle character over here. So I think this is clear to you. So what we will assume that on each and every iteration, we are in the middle of our palindromic substring. Means if we go into our left or into our right, we will see the same character on both sides. And we can easily conclude that this is a palindromic string. So over here you can see how with this assumption we are solving this problem. So I know though you can visualize this code, but the concept is still not clear to you. So let's now do a dry run over here so that it will be helpful for you to visualize the complete code of how we are trying to find out the solution of this problem. And over here, if you just notice, the complexity of this problem will be nothing but order of n square. So here if you see, we are using one for loop to iterate over each and every character over here. So for this, we will be using one for loop that will run from I equal to 0 to I equal to n. And over here, to find out that whether a string is palindromic or not, the complexity of this will be order of n, which means that the entire complexity of this algorithm will be order of n square. So I hope this is clear how we are getting the order of n square complexity over here. Now since you have understood that we are successful in reducing the complexity of the program, let's now understand the algorithm by which we will be solving this problem. And for that, as usual, we will be using our visual display board. So let's understand the problem using the visual display board. So over here, we will be solving both the problem together. That is, printing all the palindromic substring and also finding the longest palindromic substring without the dynamic program. So let's see how we will be solving this program. So to solve this program in the most optimized way, we need an additional data structure, and that is a hash set. So if you know, a hash set is nothing but a simple data structure which are used to store any data type without any duplication, which means that a hash set doesn't contain any duplicate value within themselves, which means that if I insert 2a within a hash set, it will only store a single a within itself. So over here, to solve this problem in the most simplest way, we will be using a hash set over here, and also we will be using an additional variable that will keep a counter of the length of the maximum substring that we have encountered until now. So let's see how we will be doing. So as I have already told you, we have two types of palindromic substring. One is the odd length and another is the even length. And over here, for the first time, we will be finding all the odd length palindrome that can be found over here. So let's first calculate all the odd length palindrome over here. So we'll start our iteration from I equal to 0. And over here, if you see, for I equal to 0, the first character that we are encountering over here is G. And I have already told you that a single character is the example of both the palindrome as well as a substring. So over here, this character G satisfies both our condition of being a palindromic substring. So since over here we already got one answer of our problem, that is, we got the first palindromic substring, that is why we will be storing this palindromic substring within our hash set, and we will update the length of the maximum palindromic substring by 1. So let's insert this G into our hash set and let's update the value as 1. Now comes the fun part. Now what we have to do, since we are considering that whatever the index which we are targeting, that is for I equal to 0, that is the middle of our palindrome, which means that all the characters which are lying on the both sides of this character should be equal. Otherwise, it is not a palindromic substring. So we'll see that keeping G as the center point, that is the middle of the palindrome, how long we can increase the window size of our palindrome, and we can check that whether that substring is palindromic or not. So let's see what I mean to say. So over here you can see that the character which we have encountered is G, which is of size 1. Now what we will do, we will set two pointers from here, one going into the right side and one going into the left side. And on each and every iteration, we have to check that whether the character on the left side is equal to the character on the right side. And if these two characters is equal, which means that the entire substring that we have got until now is palindrome. And otherwise, that the substring that we are calculating right now is not a palindromic in nature. So let's see with the help of this algorithm how we are solving this problem. So for the first time, you can see we are increasing our window size to 1. So over here, keeping G as our central point, we are increasing the window size over here with the help of the 2 pointer. But over here you can see that our left pointer, which is our low pointer, has already went outside our string boundary. So obviously we cannot take this substring into consideration. So we will stop the iteration over here and we will increase the value of I. So let's increase the value of I equal to 1. And over here the character that we have got is O. And as usual, O is a substring and also it is a palindromic in nature. So let's put this O into our hash set and let's also increase the window size over here. So over here you can see the characters which are within this window are also odd in length. And since this substring is not a palindrome, there is no need of increasing the window size over here, because any substring that will be having GOO inside it, which is not a palindrome, will also result in a non-palindromic substring. So we will again stop the iteration over here and we will increase our pointer to I equal to 2. Now over here you can see O is another palindrome over here, which is a substring, and over here since O is already in our hash set, so even though if we insert O into our hash set, it will not result any change within our hash set, because hash set doesn't contain any duplicate element within itself. So the hash set will remain same and the palindromic substring that we had encountered until now will be G and O. And in this way we will keep on proceeding. So over here, since O is a palindromic substring, we again have to increase the window size. So again we will increase the window size and we will see that the substring we are generating is OOG, which is again not a palindrome, which means that we will break this iteration and we will increase the pointer to I equal to 3. And in this way we will keep on iterating forward. So I hope this is clear to you until this point, and over here you can see since on our last case the pointer is going out of range of our string boundary, so we have to stop our iteration over here, and thus we can conclude that these are all the odd length palindrome which can be generated from this given string, that is Google. Now let's see how we will be finding the even length palindrome over here. And obviously to find out a even length palindrome, we have to consider a window size of 2. Thus we will be making a window size from I equal to 0 to I equal to I plus 1, which is this 2. So for the first iteration we are having a window size of 2, which is though a substring, but this is not a palindromic substring. So what we will do, we will stop our iteration and we will move forward with I equal to 1. And this time you can see that the substring that we are encountering is OO. And here comes the fun fact of how we will be finding the palindrome. Because with the help of this example, you can see how easily we are checking the palindromic substring over here. So over here for the first test case, over here you can see OO is our palindromic substring. And since this is a palindromic substring, we are blindly putting the value into our hash set, and we are also increasing the maximum length of our palindromic substring to 2, because until now OO is the maximum palindromic length that we have encountered over here. Now over here within this algorithm, since we are considering that the characters which are under consideration are the middle part of our palindrome, which means that all the characters beside that middle part should also be equal, and if it is equal we will also consider that as one of the palindromic substring. And thus what we will do, we will increase our window size, and thus the substring which we are getting is GOOG. And over here if you look carefully, this is also a substring which is palindromic in nature. And thus we will be also putting this value into our hash set. And also we will be updating the maximum length of the palindromic substring to 4. So you can see how easily we have solved this problem of finding the maximum palindromic substring. Now let's move forward with the iteration. So what we'll do again over here, since this is a palindrome, we will again increase the window size over here. But in this case, the left hand side pointer moved out of our index size. So we will stop over here and we will increase the value of I to 2. And in this way we will keep on moving forward and we'll check on each and every iteration that whether the string which we are considering is palindromic or not. And if it is a palindrome, then what we are doing, we are increasing the window size and we are further checking that whether that string which we got after increasing the window size is also palindrome or not. And in this way we will complete the entire iteration from I equal to 0 to I equal to n. So let's proceed further over here and let's see how the other values are getting calculated over here. And thus over here we reached the end of our string and we have completed the entire check of finding the palindromic substring. And over here you can see how easily after the end of the entire iteration we have calculated all the palindromic substring that can be generated from this given string, and from here also we have found out the maximum length of the palindromic substring over here. So you have seen that with the help of this simple algorithm how easily and how efficiently we have solved both the problems over here. So hopefully this video was useful to you to understand that how we are solving this palindromic substring problem. And if you have liked this video, do not forget to like and share this video. And if you are new to my channel, do not forget to hit the subscribe button and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So without wasting much time, let's see how we will be implementing the entire algorithm using our Java code. So let's go with the implementation of this entire algorithm using the Java code. So now since you guys have understood the algorithm by which we are solving this problem in the most optimized way, let's now implement the algorithm over here. And over here you can see, to implement the algorithm of finding the longest palindromic substring, I have created a class called as Palindromic Substring. And within this there is a string called as Google. So over here the way we will be implementing the algorithm is quite simple and basic. So over here let's write a function called as generate all substring. And within this function, we will be writing the logic of generating all the substring that can be driven out of a particular string. So let's call this function from here. Now since we have called our function that is generate all substring from our main block, let's write the logic over here. So as I have already told you, over here we will be running a for loop starting from I equal to 0 to I equal to n, which is the length of the string. So let's write a for loop over here. And within this for loop, we will be considering each character as the middle of the palindrome. And you know right now, there are two types of palindrome. One is the odd length palindrome and another is the even length palindrome. So we have to handle both the case simultaneously within the same loop. So let's see how we will be doing it over here. But before implementing that logic, I will be declaring an additional data structure called as a HashSet, which will basically store all the substring that are generated from a string. So let's declare a HashSet over here. So now we are done with the initial declaration of the HashSet and the for loop. Now let's write the logic of handling the odd and the even length palindromes simultaneously. And for that we have to write a utility function which will help us to determine that whether the adjacent characters which are lined on the both sides of the middle character are equal or not, and if they are equal, which means that the new string which we are considering should also be a palindrome. So over here what we will do, we will call a function called as isPalindrome. And within this isPalindrome function, we will be passing 4 arguments as our parameter. So first is the entire string, next is the ith index, next one will also be an ith index, I will tell you why. And the next one will be the set, which is the additional data structure we have declared over here. Now why I am passing 2i over here, I will be explaining it very soon. But if you have understood already, it will be great for you. So just to give you a hint, this function call is responsible for listing down all the palindrome of odd length. So basically this will determine all the odd length palindrome. And the next function that we will be calling from here is for the even length palindrome. So we'll copy the same functionality over here, and over here instead of passing I, we will be passing I plus 1. So I hope this is clear to you why I am passing 2i over here and why I am passing I plus 1 over here. Because of the fact these are actually determining the window size of our palindrome. So as I have already told you that for the odd length palindrome, we are considering a single string at a time, and at our initial stage, the value of I or the value of the window size is 1. Whereas in case of the even length palindrome, the value of our window size is 2, which means that we are considering 2 characters at a time. And that is why over here we are sending I and I plus 1 over here. So now if you guys are clear with this concept, let's proceed with implementing the function that is isPalindrome. And the logic for isPalindrome is very simple and straightforward. So let's first define the method over here. Now over here we will write the main concept of finding the palindrome. So let's see how we will be validating the palindromic substring over here. So what we will be doing over here we will be writing a while loop. Now why over here I am writing a while loop, you will get to know very soon. But let's first write the while loop over here. And within this while loop, we will be putting the condition that whether the left hand side pointer is equal to the right hand side pointer or not. And if they are equal, which means that the substring that we got till now is a palindrome. And if it is equal, we need to again extend our window by size 1. So let's implement that logic over here. So what we are doing, we are just checking the left hand side pointer with the right hand side pointer. And if it is equal, then what we have to do, we have to increase the size of our window. And for that, we have to move the left hand side pointer more towards left and right hand side pointer to the right. So I hope this logic is clear to you. So now what we have to do, since we already have validated that this string is a palindrome, which means that all the substring that are entering within this block should be a palindrome. And for that, we have to store that palindromic substring within our HashSet. So we'll store the palindromic substring within this HashSet. And this is basically the entire logic of our algorithm. But one more condition you have to put over here, that is, over here we have to put a termination condition over here. That is, we have to check that our left hand side pointer should be always greater than 0 and our right hand side pointer should be always less than the length of the string. Otherwise, we will get an exception over here. So hopefully this logic is clear to you. So what we are doing over here, for the first time, we are checking all the odd length palindrome, and that is why we are passing a single length character over here. And over here in this function, we are checking whether it is palindrome or not. And obviously, since it is a single character, it should be palindrome. And thus it will go inside this loop and it will add that single character within our HashSet. And since this is a palindromic substring, we have to increase our window size, and thus we have to increase our left pointer towards left and we have to move our right pointer towards right. And in this way, we will be keep on checking each and every substring that whether they are palindromic or not. And as soon as one of these conditions becomes false, the loop will terminate over here and we will come to our next statement, that is over here, which is actually determining the event palindrome over here. So I hope this is clear to you. If not, please do a dry run of this code so that it will be much more easy for you to understand the code. Now the last and the final activity that you need to do over here, and that is we have to print the entire palindromic list over here. So for that, I will be putting a sysout over here. And over here, I will be printing the entire set which we have generated from here, which is basically containing all the substring that are possible to generate from a given string. So let's run this program and let's see whether we are getting all the output as expected or not. So let's run this program. And great, you can see over here we have got all the palindromic substring that is possible to generate from this given string, which are nothing but all the characters over here. Apart from that, we have two more strings, that is OO and GOOG. So I hope this is quite clear to you right now that how with the help of simple line of code we have implemented this whole algorithm. And one more enhancement I want to show you over here, that how with the help of this algorithm you can find out the longest palindromic substring over here. So for that, what I will be doing, I will be declaring a variable over here called as max length. And over here within this function, as soon as I'm getting a substring as a valid palindrome, I will be putting a check that whether the length of this substring is greater than the max or not. And if the newly generated substring has a length greater than the max length, then we just need to update the max length over here. And that's it. With the help of this simple check, you can easily find out the longest palindromic substring that exists within your string. So let's also print out over here. And let's run this code. And great, you can see we got the result as 4, which is our longest palindromic substring, that is GOOG. So I hope you guys have thoroughly understand the way we have tried to implement this algorithm over here. And if you have liked this video, please do like and share this video. And if you are new to my channel, do not forget to hit the subscribe button and hit the bell icon so that you never miss an update from my site like this and you are always ready for your next interview. So without wasting much time, let's end this video and see you on our next video. Thank you.